This video, we are going to be just solving all sorts of pieces of shapes that are inscribed within a circle. So this one is you have an inscribed equilateral triangle in this shape or in this circle. All right, so the corners kind of hit nicely and all equivalent. So all the sides are the same because of the equilateral triangle. All the angles are 60 degrees. So that's 60, 60. And then this thing is 60, but it's being cut in half. So that's making this 30 and 30 degrees. The sides are the same. So we're going to answer a bunch of little questions associated with this. So first thing that I want to do is I want to take this triangle and kind of roll it so it's standing upright. Okay, so I want to roll it to like that. I have this height right here. And what I get out of this is if I just kind of start to focus on one side, this is 13. All right, this is C, B rolled to here, and A rolled up to the top. All right, so this is 13. That would make this 13, which make the whole length 26, which makes that 26. So what we get out of this is, let me just focus on this triangle, is we get ourselves a 30, 60, 90 triangle. So there's relationships with that. Let me refresh. When you have a 30, 60, 90, okay, everything's kind of based off of the shortest side. Shortest side is across from the 30-degree angle. That's X. Hypotenuse is exactly twice whatever that measurement is, and the height is X, that length, times the square root of 3. So with that relationship, I can start to fill in pretty much everything, and then I can answer all sorts of questions that they're asking. So we already know that the bottom is 13. Hypotenuse is always twice that, which matches what we already have. And then this height is 13 square root 3, which I'm going to throw that in the calculator and figure out what that value is. So 13 square root 3 turns out to be, we'll say 22.52. 22.52 is the height. All right, so questions that they're going to ask. What's the height of the triangle? 22.52. Label-wise are millimeters. BD is one of the sides. D is actually in the middle here. So BD is 13 because it was the same as that. So 13 millimeters. BC is all the way across. So that's going to be 26 millimeters. And then CAB is CAD. CAD is going to be this top angle, which is 30 degrees. ACD is this bottom angle, which is 60 degrees. And the area of the triangle. Well, now that we have the height and the base is 26, we're looking at half 26 times this height of 22.52. All right, and if you throw that all into the calculator, that gets you 292.76 millimeters squared. All right, so that was finding all sorts of different pieces, and the fact that when you roll this over, you get yourself an equilateral triangle. That made a big difference to be able to help us figure out, well, the equilateral, but when you cut it in half, it turned into a 30, 60, 90, and that's where we got all sorts of information from. So that's not uncommon with these types of shapes to create a 30, 60, 90 or a 45, 45, 90 and not have to do any kind of trig or Pythagorean theorem to kind of figure out what all your values are.